Right. Maddie, this shouldn't take very long. A lot of these I'm gonna leave for you to do because this is skills you do need to have. Um, the things you should or want to remember is that when you're multiplying, there we go, get my pen book in here, that so there's two basic operations you're gonna have to do. There's multiplication, and I'll do it with x's here. And what you want to remember is that when you multiply two x's by themselves or times each other, those two exponents get just added together. So you just have to figure out what the sum is of the exponents. And you're going to have lots of exponents that are just ones. So like when you see x times x, those really have ones on them for exponents. We just don't show them. But the answer is then x to the 1 plus 1 or x squared. Now, that's not the only way to think about this. The other ways to think about it is, hey, x times x is just abbreviated as x squared. So that one's kind of natural for us to do. But if they're ever not just ones, then you can't use that logic and you have to go back to this general formula that always works. So when you're multiplying, always add the exponents. Generally, in these problems today, it'll just always give you 1 plus 1, 2. And then the other thing you're going to have to do is recognize when you have like terms and just make sure that if you have like terms, you add and subtract them correctly. So here's a couple of examples. These are like terms because the x's are to the first power. And so when you add like terms, you just add their coefficients. These are like terms down here because they're both x squareds. Uh, and again, you just combine them by combining their coefficients, but in this case, it's subtraction. You keep that exponent, right? You're counting these coefficients, count up the number of x squareds that are added together. And so when you get a total, you're just saying, hey, I've got two of these x squareds. It's like x squared plus x squared. We just write it as 2x squared because that's more convenient. Multiplication is a shortcut for adding a bunch of things. So um, I'm going to walk through a few of these things to kind of help you out. I won't do yours for you. I'll just do one that is similar. Okay. So it shouldn't be too hard to follow when you do your own. So maybe I've got like x times x minus 3 um, minus 2 times x plus 4. Now I've put in some negatives here. This one obviously only has positive symbols in it, so these are good. That will be easier. The next one has some negatives in it, so this will help you with that type of problem. So here we go. And there's kind of two separate problems they're giving you here. So here's the first one you have to figure out. You had to do that multiplication first, and then you also have to do this multiplication. And notice I didn't highlight the negative sign. Uh, there's two ways to do this. I am going to eventually highlight that because I like to take the negative sign with my distribution. And I think that'll work best for you as well. So here we go. You'll see the teacher oftentimes just, draw this arrow that goes from what you're distributing to the first term you're distributing times. So there's that x times x that I was talking about. These both have exponents of 1, so you add them together, and that gives you that x squared. When you do this distribution, you want to keep track of signs. So this is a positive x, 1x, times a negative 3. So 1 times negative 3, you're just multiplying the coefficients here. 1 times negative 3, you end up negative 3, and that is x's. So negative 3x, and you're done with that distribution. Now, this next one, when you have a negative sign, you could just distribute the 2, uh, but then you'd end up having to distribute the negative second. So they both get distributed. So it's best to take both of them at the same time. So I'm going to capture that. But since I'm taking the negative away, I actually have a plus here. And then I take the negative 2 times x, which gives me negative 2x, and negative 2 times 4, which is negative 8. And so this frequently happens. So lots of times you want to think ahead here a little bit and just go, hey, when I distribute this negative, is that going to give me a negative result? If the answer is yes, then you really don't go plus minus. You just say, hey, it's going to be a minus 2x here. because plus a negative is the same as just subtracting. And then after we get done doing that, you look for your any like terms. And here we've got an x term and an x term. So these can be added together or combined. So it's take away 3x's, take away 2x's. That's so negative 5. So our final answer is just x squared minus 5x minus 8. And that's it. And all of them just go that way. I don't think there's any changes here. I'm going to look through them. Distribute your x. Oh, this is double distribution. So there's a change. Here we're just distributing x. Here we're just distributing 4x and negative 3. Here we have to do a double distribution. So let's look at one of those. I'll set up again, just something similar to it. Maybe I've got x minus 5 times x minus 2. We'll make them small. Plus x plus 6 times x minus 2. And I've used x minus 2 twice here because they've used x minus 3 twice. And so I'm trying to think um, what he may want you to do on this. I'm going to do it two ways, and then you can decide if either of these look familiar to you based on what your instructors told you. So the first way to do it would be to distribute the x, then distribute the negative 5, distribute the negative 5. This is called double distribution or just distribution. You do the same thing over here, and then you just combine all those like terms. So let's see how that works out for us. In this problem, I'd go x times x, x squared, x times negative 2, negative 2x. Again, I'm just taking the one that's not shown in front of this times the negative 2 and times the x, giving me that total. Then I distribute negative 5. When I distribute my negative 5, I know that's going to give me negative 5x. And so frequently I'll line it up right underneath that one because I know those two are going to combine together. And negative 5 times negative 2 is positive 10. So the result of my first multiplications is that sum. And I just do the same thing over here, x times x, x times negative 2, 6 times x, oop, that's an x term, so we'll line him up, and that's minus 12. Put all those together, that gives me a positive 4x in the middle, minus 12, and these two have to be added together. So now again, I'm looking through as a sum. I'm not multiplying. I'm just looking for like terms. So this is 1x squared and 1x squared give me a total of 2x squareds. Just adding those lead coefficients. So we'll say, hey, these two combine give me 2x squared. This negative 7x and this positive 4x add up to negative 3x's. And my last one's the 10 minus 12 is negative 2. So that would be one way to do this problem. I'm going to go ahead and try it a different way, and we'll see if this is something that looks more familiar than the method I just used. So I'm just going to erase all this stuff real quick. And we'll take it a little bit more mathematical. You can believe it. So when I noticed I was making my dummy problem up, I noticed these were both x minus 3. So I built the same thing. So this is like a common factor in both of these terms. It'd be comparable to this. So you can kind of see, let's say it was x minus 5, and maybe this thing was taken times a 3, plus a 3 times an x plus 6. Okay. If that was my problem, I'd say, hold it, I'm taking 3 times both of those. Why didn't I just grab this 3, pull it out front, and then it'd be like, hey, I got to take the 3 times the x minus 5, plus I have to take the 3 times the x plus 6. So we could rewrite it that way. And this factor that was in both of these terms, I got to just use it once out front. And that kind of speeds up my distribution because now I can do this additions in here, like x and x is 2x. And I just have to take a 3 times a 2x. So this would speed it up if they had a common factor that I could pull out front. See this x minus 5, he stayed here. X plus 6, it stayed there. Those guys, you could have left them like in parentheses like this, but those parens, if you did, don't mean anything because there's nothing right here directly in front of it. And there's no exponent. So there's nothing to keep these parentheses, so you could just drop them, making it like I had it written. All right. So let's go ahead and apply this concept now to this bigger problem. So in this bigger problem, my common factor is x minus 2. So just like I pulled out that 3 in my example, I'm going to pull out that x minus 2, and that would leave me with this x minus 5 plus this x plus 6, just like that. And that gives me x minus 2, and see, now I can clean up the stuff inside here. X and x, that's 2x. Negative 5 plus 6 is plus 1. And now I don't have to do near as much of that distribution. I just distribute there, giving me 2x squared. Distribute x times 1, giving me 1x. I'll do negative 2 times 2x. That is not a 1x that I wrote just there. Plus 1x. Then I do the green one, negative 2 times 2, which is negative 4x. And then lastly, negative 2 times 1, negative 2. Total all that up, and I hope that's the same answer I had before. So that's the general idea behind oops, this type of problem. So I found that common factor. Now I'm not going to do that one for you. I've kind of illustrated how to do it. I'm going to look for one though that I will do for you here. See if we have one that might look tricky. Yeah, here's one that looks really tricky. I'll show you how to do this one exactly, and then that should help you with this, and this one here, because this is the toughest one out of that group of 6 here. So again, as I try to analyze this, I can see I'm going to have to multiply these two factors together. I've got to multiply these two together. Then I've got to subtract those results. But I also notice they both have a common factor, x plus 5. And they're not the same position, but that doesn't really matter. Okay, when we multiply, things are commutative. So 4 times 6 equals 6 times 4. So that x plus 5 can be on either side in its term. So don't let that bug you at all. All right, the thing got really thin here for some reason. We'll keep going. So I'm going to grab this common factor. Okay, good color. So this x plus 5 and this x plus 5, that's like that 3 I showed you in that little example. And I'm going to go ahead and pull that x plus 5 out. So I go x plus 5. And let's see what I would have left then. So in my first term here, I've taken out the x plus 5. That leaves me with just 3x plus 7. And I don't need to have parentheses with it. So that's essentially the same problem as this and this. Okay? Then I got this darn minus sign that I got to be careful of. Here's why. When I pull this x plus 5 out, that minus sign is going to stay there. And that minus sign is going to have to be distributed because it's subtract and it's this whole quantity. So when I do my subtraction here, I'm going to have to go minus. I'm going to have to wrap in parentheses this 2x minus 4. And then I got to close my parenthesis at the very end because I threw in this pair. I got to close this guy. Parentheses always have to have an open and a close on them. And so now I've got to do a little distributing in here. And so my next line, x plus 5, I got 3x plus 7. I distribute that negative, so I'm subtracting that second half of the equation. Negative times negative is positive. Clean it up a little bit. These are like terms that just simplifies to 3 minus 2x. These are like terms, and that's 11. And then I finish it by just doing this multiplication here. x times x, x times 11 times x, 5 times 11. Assuming I'm doing my math correct early in the morning, I come out with that solution. Okay, so that'd be the simplest form. All right, hopefully that'll get you through your 6 problems there. See, Max tries to do this here, so let's take a look at it real quick. It looks like he's trying to use this technique we just used. So he's trying to factor this, and if you look at it, they both have x plus 3's in them. So in our math, we would pull that x plus 3 out, just like I did here, where I pulled out that x plus 5. I had that minus sign, so I had to trap it in front to make sure I subtracted this quantity 2x plus or minus 4. So let's see if Max here did this. X plus 3 pulled out front. Then he was left within the first term, the 5x plus 2, then the minus sign, and see, he only subtracted 2x. He has to subtract the quantity 2x. So he needed another parenthesis right there and then one to close. I shouldn't put that in blue. I should highlight that this one is in blue there, and then he's got to close this guy. So it should have looked like that. Then he would distribute this negative. So he could have jumped to this line, no parentheses, and just put negative 2x plus 3. That would have been a subtraction of this net 2x and this negative 3. Or his next step should have had the parentheses, and then he would have had another step to show the distribution. I'll let you work out the details to get the exact solution and what it should look like. And by the way, I think your teacher wants to go one step further here. You should go ahead and multiply that all out to get the full simplified answer. Number 10, factor each of the following quadratic expressions completely using the method of grouping. All right, so in the method of grouping, we try to find a pair of terms. So I'm going to take the first pair and the second pair and wrap them in parentheses. So we go, hey, I'm going to group this two and this two. And you hopefully can find a common factor that comes out of this pair and a common factor that comes out of this pair. So let's see here. When we do this, we've talked about it before. You do numbers first. So 10 and 6, what's the biggest thing they're divisible by? Check 6. 6 is divisible by 6, 10 isn't. The next thing 6 is divisible by is 3, 10 isn't. 6 is divisible by 2, 10 is. So we can take a 2 out of everybody. Right? And then you do your variables and take the one with the lowest exponent. So 2x comes out. And remember, this is just division. I'm dividing out 2x from each of these, leaving me with a 10 divided by 2 and x squared over x. And then here on the second one, 6 over 2 is 3, and the x is just completely canceled. Then I check my second pair, and we'll have 21, that's the smaller number, is divisible by 21, 35 isn't. 21 is divisible by 7, 35 is also. So I'm going to take a 7 out. Get that back there. Let's pull out this 7. And that would leave me with 35 divided by 7 and 21 divided by 7. Notice I didn't take any x's out because 21 does not have an x by it. And thank goodness when I did this, this 5x plus 3 was a common factor. Okay, so now just like I could pull that 3 out as a common factor, I can pull this 5x plus 3 out as a common factor. And that leaves me with a 2x in the first term plus a 7 from the second term. And so that is my factorization by grouping. Uh, Try this next pair on your own. Again, I would group the first two. Be careful here when you group the second two. In fact, I'm going to help you group the first two. 12x squared plus 3x. You always, when there's a minus sign at the lead of this second group, just because of that distribution we've been talking about, You always want to go plus and then minus 20x minus 5. You need to do that. So when you're grouping it, whatever's out here, if you distribute it, which is just a positive sign, you'd still get negative 20 minus 5. If you were not to do that, I get students making this mistake all the time. They go, okay, minus, and they go 20x minus 5. But that is not even equivalent to this anymore because this would be minus 2x or 20x rather. Sorry, it's not incorrect because of that. It's incorrect because of this would give you negative 20x plus 5, but that's not what I started with. And so you have to always put a plus sign before you group and capture that negative sign. It doesn't change anything in there. But then when you start to try and figure out your GCF and it looks like a 3 and an X come out. On this one, when you say, oh, I got to take out a number and you realize they're both divisible by 5, you want to take the negative out at that point. You go negative 5. When I divide these by negative 5, it becomes a positive 4x and a positive 1. And when I do this 3x on this side and divide by 3x, you'll see I get a 4x and a positive 1. And again, if I do my math right and the problem is of this type, I should end up with this common factor that I can then pull out front and leave me with whatever's left over. All right. Hopefully that'll help you out. Finishing up that one. That one's not quite done. Factor each of the following cubic expressions completely. It looks like he's teaching you all of these things as factor by grouping, I think. Let me just run through a few of these. We'll just see what's going on here. So 5x cubed plus 2x squared, that could be my first group. Got that minus sign, so I'm going to go plus, and I'm going to capture the negative. I would check for GCF for the 5 and 2. There isn't one. I check my variables. Ooh, they have x's in common, and the lowest exponent is 2. And so if I take that x squared out of both of these terms, x squared would cancel most of that. X squared would cancel all of that. I'd be left with a 5x plus 2. Great. My next one here, I could take a 4 out of both of these, but it's got a lead negative, so I want to take out a negative 4. That would give me a negative 4 out here that I'm taking outside. 20 divided by 4 is 5, and now it's going to be positive. 8 divided by 4 is 2, and that would be positive. Great. There's my common factor, 5x plus 2. So I take that 5x plus 2, and pull it out front. That's like a 3 or whatever that common factor is. I pulled it out front, and it left me with, in the first term, an x squared. Just remember, this thing is gone from both of them. And from the second term, a minus 4. And if you don't recognize it by now, learn to memorize it. This is that difference of two perfect squares. And so this always just square root and square root mentally. You don't really show that step. But the square root of x is x, x squared is x, the square root of 4 is 2. So it's x minus 2, x plus 2. And that always works as long as that's a minus sign and these two can be square rooted. Means they come out even when you square root them. But again, you don't show that little square root because that's not really true math. That's not how you do it. It just is how you recognize and figure out that factorization. Okay, so that thing has three terms in there, three factors when you get done. And I think that's pretty much the way you go through all these. Group the first two, group the last two, capture a negative if you need to. Pull out the GCF and factor as far as you can go. Um, Factor each of the following expressions, rearrange as needed to produce binomial pairs with common factors. Binomial pairs with common factors. Um, I'm taking a look here to see what's going on. I'm assuming we're just going to group the first two, group the second pair. Notice I captured that negative. Always put a plus sign between your two groups. Check for a GCF in our first one. No GCF in that one. This is an X. Nobody's got an X here. There's no A's or C's in this one. Check this guy. I could pull an X out of him. Well, none of these. So, like the first term is I can't pull anything out. The second one's I could pull out X, maybe a negative X, leaving me with a C minus A. But that doesn't match anything over here. So we're to do this rearrange here. Let's see if we can figure out how to rearrange it. So if I look at these factors, this first term just has X's in it. This one has no X's. This has X's. This one has X's. So this and this share a common factor with this X squared. So I'd want to group him with one of these two. Let's see, the second term, AC, which doesn't share anything with the X squared, does share something with this term. It has a common C, and it shares something this with this one, a common A. So I don't think it's really going to matter how we group it, but I'm certainly going to put the X squared out front. And I'm just going to put the negative CX second. Notice I take the sign with it. I'm going to put the positive AX third and the negative AC fourth. And I'm just guessing here. I'm just rearranging my terms to see if, let's see, if I group these first two together, it would mean I could take an X out. Okay, so I took an X from both terms. If I group the second two together, I could take an A out. Hey, there we go. Rearrange the expressions to produce binomial pairs with common factors. I assume he just wants us or she wants us to stop right there. Okay, so play games with it, rearrange it, just look at them. I think this one I've got X, Y, so I'd want to pair him maybe with this one or this one. And this is A, B, so he could go with either of those two. It shouldn't really matter. Here, I'm going to put the first and the last together, and I'll put AY and AB together. Now, you may ask why I keep putting why I chose to put AY here first. I put him first because this is like my second pair. This is my first pair. This one has the Y in it, so I want that first as well. And it looks like this one has, so I'd group and group. I can take an X out of the first pair, Y plus B is left. I could take an A out of those, Y plus B is left, and I think you're done. So that's all that's going on there. Consider this expression. Enter this expression on your calculator and find where it is equal to 0. Provide evidence and factor it completely. Okay. So I'm going to leave it for you to graph that thing on your calculator. It's kind of a pain for me to pull that video up or kind of work that in there. But graph it. Use Desmos if you can. When you use Desmos, it's going to cross. In fact, this one will do. I don't know exactly what it looks like, but it's cubic. So it's going to cross probably 3 times, something like this. In fact, I'm going to show you how many times in just a second. But find those things. Draw a picture of the graph. He wants you to prove it. Draw something close to what it looks like. Let's find out what it looks like. So I'm going to take this guy right here, and I'm going to factor it complete. Okay, it's got 4 terms, so I'm going to group the first two together. I'm going to group the second pair together. Notice I'm capturing the negative sign. I'm going to GCF an X squared out of those two. And I'm going to GCF 9 out of both those, but I want that negative out of there as well. So that when I divide by this -9, it makes it a positive 1x And 45 divided by -9 is -5. And then there's that common factor that I can pull out front, leaving me with, in the first term, the x squared. In the second term, the -9. This is putting everything together we've been looking at here. This is that difference of squares. I can square root both these. They have a minus sign between them. So the one in red factors as an x and then minus a 3, and an x and then plus a 3. And so these factors, you should find out that this one will produce, it'll cross right here at 5. And you'll also find one that crosses at 3. I'm gonna redraw this graph here real quick, because now that I know these factors, I can actually tell where my graph crosses the x-axis. There's a direct relationship between that. So this one's going to produce it crossing at 5. This one will produce it crossing at 3. And this will produce it crossing at -3. And so this graph, draw a sketch of it, but it must look something like this. It may go up a little bit higher somewhere around there or a little lower there, but it's going down here, crossing, going up like that. Alrighty, that should get you through all of these things, and you'll be able to figure out those. If you got questions or want me to check it, just send a picture of your answers back, and I will take a look.